This video shows you how to determine the sample size you need to do an effective time study based on 4 variables. So I'm using the data from 10.18 at the end of chapter 10, the supplement to chapter 10. And they give us this information here. So they tell us what the X bar is, or the average. So they did take a sample. They wanted to know what the average of that sample was. It is 3.2 minutes, and they figured out the standard deviation, which is 1.28. In the homework that you're assigned, they actually give you, it looks like the actual times for a sample, and there's 1, 2, 3, 4, 5. There's 5 sample times. You'll have to average those together and then calculate the standard deviation. Remember, in Excel, this is pretty easy. The function for average is equal average, and the function for standard deviation is equal STDEV, standard deviation, and then highlight those 5. And so that would give you the X bar and the standard deviation. In 1018, they already calculated those for me. The other things they've given me is they want a confidence. They want to be 99% confident, and so that translates into a z-value of 2.58. On the exam, I will always tell you what the z-values are. For your homework on page 416, common z-values, they have table S10.1. A 90% confidence is 1.65, a 95% is 1.96, a 95.45 is 2, 99 is 2.58, and 99.73 is 3. These are basically normal distribution, what they can capture within certain standard deviations, or the z-values. And so 1.28 captures, 2.58 captures 99% of the distribution. The last thing they give us is they tell us that we want an error, or basically a standard time within 5% of the true value, and so that's written as an H value. Now, we will give you the formula on the formula sheet. It looks like this. So the sample size here, and we're just going to plug in the numbers. Sometimes they will not tell you that, for example, they just want an absolute error, a certain percentage, as compared to plus or minus around the true mean. So we have this case where they have the X bar and then plus or minus within 5%. Sometimes they'll just tell you that they want this error. And so the only thing that's changed between these two formulas is that idea. So let's go back and use this formula. So instead of trying to do in one cell, I'm going to spread it out to make sure I do my calculations right. So the first thing we want to do is we want to calculate, we want to multiply the Z times the S. So that's that first, the top portion of that equation. We then want to multiply the H times the X bar. So let's go ahead and do that. H times the X bar. Like I was telling you, sometimes they will not give you the X bar or plus or minus or within a certain percentage. They'll just tell you what the absolute error is, and then we would just use that. We wouldn't need to multiply that. These then we're going to divide the top of the equation by the bottom of the equation here. And I'm just following the formula that was given to you. And then we are going to take the square root of that. So we will take, or I'm sorry, not the square root, we're going to raise it to the power of 2. We're going to square it. So in Excel, we use this little caret sign there to do exponents, and so we're going to square that value. And so what this tells us is that for us to meet these parameters based on the sample we did, so we took a sample, we don't know what the n was. In your problem, they give you the n so that you can see how well that compares to how many observations you really have to make. But we did take a sample. We determined the average was 3.2, standard deviation was 1.28. We want to be 99% confident, so that is definitely going to up the number of observations we'll want to make. If we are willing to reduce our confidence level, then the number of observations will be reduced. The other thing that can impact this has to do with what, within, how close do we want to be to the true value, how confident will we want to be in capturing 99% of the distribution. If you only are willing to, if you were willing to do 90% of the distribution, that would reduce the observations. If we were willing to allow a little bit more error here, within 10% of the true value or within 20%, that would reduce the number of observations. And if the standard deviation were to go down. These all affect the observations. This one's a fairly high confidence level, 99% of the distribution. We want to be within 5%. And our standard deviation is in the middle. It's not really low, it's not really high. But basically what we're saying is we would have to do 426 observations to meet these parameters, to be 99% sure that we captured the distribution, to be within 5% of the true value based on what we sampled, based on the X bar, the average, and the standard deviation for the items we sampled. And that's how you calculate then the number of observations you need to make in regards to time studies based on these parameters.